Hi, my name is Earley, and I'm a PhD candidate at Northwestern University in biomedical engineering. I do my research at the Rehabilitation Institute of Chicago's Center for Bionic Medicine, and my work focuses on prosthetic devices. Specifically, how can we allow an amputee to use their normal motor adaptation while still using their device? Now, before you run away, let me explain that for you. Motor just means movement, and adaptation just means correction. So motor adaptation only means correcting your movements. Motor adaptation is actually something that you experience quite often in everyday life. Imagine picking up a water bottle that you thought was full but was actually empty. When you lifted it, it probably went way higher than you were expecting. And moving forward from that, you probably only used the amount of effort you needed to actually manipulate this water bottle. That, in essence, is motor adaptation. Your brain is sending commands down to your hand, and your hand is telling your brain what it is that actually happened. It's relatively easy to understand this in non-amputees, but when you add a prosthesis into the loop, it becomes a little bit more complicated. First, the brain can no longer tell the hand what to do. It can still talk to the muscles and tell them to contract, they're just no longer attached to anything. However, we can use these contracting muscles as our window into the brain. The same way that Siri listens to you speak and picks out patterns associated with different words, a prosthesis can listen to electrical signals generated by contracting muscles and decode those movements someone is trying to make. It's like playing a game of telephone, where the brain tells the muscles what to do and the muscles tell the prosthesis what to do. But you have to hope that the prosthesis heard correctly. In my field, a lot of work goes into developing different ways to control a prosthesis. But because all of these different methods can only predict the movement that a person wants to do, there's always a possibility of it doing the wrong movement. So what happens then? Well, right now, the only way to know that the prosthesis did something wrong is for you to watch your prosthesis while you use it. When an error does happen, the only thing someone can do is to try the movement again, or if that still doesn't work, try to make a different muscle signal that will result in the desired movement. This is where my work comes in. Given that communication is so poor in both directions, I aim to improve this and allow amputees to use their normal motor adaptation while using a prosthesis. I believe that this will restore greater functionality and overall improve their quality of life.